So our next lesson is on slope and rate of change. So we're going to talk about how to find the slope of the line, the different types of slopes that there are, and then how that relates to finding a rate of change. So the slope of a non-vertical line is the ratio of the vertical change, which we often refer to as the rise, to the horizontal change, which we refer to as the run, between any 2 points on a line. Now, we often refer to slope as rise over run because of this, because if we're looking at a coordinate plane, the change vertically, which would be your rise, over the change horizontally, which would be your run, that ratio simplified is our slope. Now, this formula here, delta y over delta x, this little triangle is the Greek letter delta. It basically is telling you the change in y over the change in x. Now, that can relate to a graph, like on a coordinate plane. It can also relate to things like miles per gallon, like the miles change in miles over the change in gallons, or dollar per hour, the change in the amount of money made over the change of hours. So we can see that while, yes, this is useful for graphing, it's also useful for finding our unit rates and things like that we did in the last chapter. Now, if we don't have a graph or a table of data or something like that, that we're using rise over run to find our slope or rate of change, we can also use the slope formula, which is simply just finding the difference between the two y values and then setting that up over the difference of the two x values. So we're subtracting the two y's, subtracting the two x's, and setting it up as a division or ratio. Now, it doesn't matter which of the y points you start with to do your subtraction or find the difference, as long as you stay consistent. So if you start with your second point and then subtract the y from the first point, you can do the same thing on the x's or vice versa, as long as you stay consistent. That'll make a little more sense when we do some examples. All right, so let's talk about the first type of a slope that you might come across, and that would be a positive slope. So if we look at this line here, it's going upward as we go from left to right. And if we're going to do the rise over the run, we're going to look for that vertical change. So that would be my rise. So my rise is going to be the vertical change. So going from one point on my line to another, and I usually try to go left to right just to stay consistent. So if I rise 3 units here, my rise would be positive 3 because I went up. And then I'm going to run 1, 2, 3, 4, 5 units to the right, and I'm going to keep that 5 positive because I went left to right. Now, if that could be simplified, we would do it, but 3 over 5 is already as simple as it can be. You can't reduce 3 over 5. Now, let's just say you didn't have the graph here and you couldn't count rise over run. Well, you'd have to find the vertical change using one of these formulas over here on the right. So if my points here are -2, 0, and 3, 3, then I would have to label my 2 points, x1, y1, x2, y2, whichever order doesn't matter, so you could flip-flop those if you'd like. And now to find my slope, I would have to find my change in y, which I would find by subtracting. So you could do 0 minus 3, or you could do 3 minus 0. However, whichever direction you decide to go in, you have to stay consistent with the x's. So since I chose to do my y2 minus my y1, I now have to do my x2 minus my x1, which would be 3 minus -2. Now remember, when you subtract a negative, that's really changing to a positive. So we end up again here with 3/5. So as you can see, both of these slopes were positive, right? The answers that we got were positive 3/5. So a line with a positive slope rises from left to right. And the way I remember this is if I write my name on the line, okay, whatever name you want to write on there, if your name is going upwards, then you know it's positive. If your name's going downwards, then you'll know it's negative. So let's talk about a negative slope now. we take a look at the next example here, this slope is going the opposite direction as the last one. So instead of going up as we go left to right, this one's going down as we go left to right. Okay, now again, we have these 2 points already kind of marked on our line. So if I want to go from one point to the other point, I'm first going to use rise over run. Since I have the graph in front of me, I'm going to use this method because it's usually the quickest if you have an actual picture of your graph. So this time though, my rise, I'm going to be going down. And if you'll notice, each of these boxes on the grid is going by 2. So I'm going down 2, 4, 6, 8, which gives me a -8 for my rise. And then my run is going left to right, 2, 4, 6, so that would give me a +6. Now, when I write my answer for this one, my slope would be -8/6, but I want to simplify or reduce that fraction to 4/3 or -4/3. You don't want to put slope into a mixed number or a decimal unless you're using it as a rate of change. But for just graphing, finding slopes on graphs, we would want to leave it in improper form, just simplified. Now again, if you did not have the picture of the graph and you could not use rise over run, then instead we could use our 2 points and we could label them x1 and y1, x2 and y2, and then we could use the slope formula up at the top of the notes. So if you remember, what I like to do first is look at my 2 y values and see which way I'd like to subtract them. So do I want to do -2 minus 6 or 6 minus -2? So the choice really is up to you. I'm just going to go ahead and do -2 minus 6. But whatever you choose for the y values, you have to stay consistent for the x's. So since I'm going to do y2 minus y1, I'm now going to do x2 minus x1, which will be 4 minus -2. Now, keeping in mind when you when you subtract a negative, those 2 negatives become positive there. So this is -8/6. And of course, that is going to simplify to -4/3, which is the same thing we got when we did rise over run. So a line with a negative slope falls from left to right. And like I said before, if you wrote your name on the line, because we always write from left to right, then you can see your name is going downwards, and then you'll know, oh, hey, that's a negative slope. Now, there's 2 other types of lines you could come across. One would be a horizontal line. Now, if you think about rise over run in this situation, if I were like, okay, what is my rise to get from one point here to the other? Well, I'm not rising anything. I'm not going to go up or down. I'm just going to go to the side. So my rise in this case would be 0. Now my run in this case, the horizontal movement from one point to the other would be 1, 2, 3, 4, 5, 6, 7. So I have 0/7. Now 0 divided by anything is just 0. So in this case, I would have a slope of 0. So let's see what that would have looked like if I had plotted, or I'm sorry, if I used my 2 points in the slope formula. So if this was x1 and y1, x2 and y2. So to use my slope formula, I would, of course, first look at my 2 y values and decide how I'd like to subtract them. Well, in this case, it doesn't really matter because they're both the same. So 2 minus 2, and then I can do either 4 minus 3 or -3 minus 4. Because 2 minus 2 is the same in either direction, it doesn't matter. So 4 minus -3, that gives me a +7 on the bottom, a 0 on the top. Again, 0 divided by anything is 0. So a line with a 0 slope is horizontal. All right, and then moving down to a vertical line. So here we have a vertical line straight up and down with these 2 points marked. And this time, if I was going to find my rise over my run, I would notice that I'm going to rise 1, 2, 3, 4, 5, 6, 7. But then when I go to run, there's no horizontal movement in either direction, so there's a 0. Now, a lot of people might think that this is 0, but it's not, because when you're dividing 7 by 0, you're asking yourself, how many times can I fit 0 into 7? Well, 0 doesn't take up any space, so I guess you could fit it into there an infinite amount of times, which is why we would say that our slope in this case would be undefined, because there's no number that we can use to define the amount of times that 0 would fit into 7. Now, if you were to do this with the slope formula, and you have points 1, 4, and then 1, -3, I'm going to subtract here my y's. Now I'm going to choose to do, I guess, I'll stick with my pattern. I'm going to do -3 minus 4. So then I'm going to have to do 1 minus 1. Again, I have -7 over 0. Again, 0 is underneath the fraction bar. You know it is undefined. So that's one way that I remember it. I just think of under, undefined. So when the 0 is under, it's undefined. If the 0 is on the top, then it just equals 0. So of course, in this case, a line with an undefined slope is vertical. Now, make sure you're able to recognize what type of slope you're going to get for your answer just from looking at the shape or just how you could describe the line. So the way I remember these two is that if I'm looking, if I think of slope, I think of skiing, right? And so I think to myself, okay, I could ski a positive slope. That's on one side of the mountain, right? I could ski the negative slope. That's on the other side of the mountain here, going downward. I could ski a slope of 0. I just wouldn't really go anywhere, but I could still stand on there and safely kind of move around. However, I cannot ski an undefined slope, because if you tried to, you probably would not survive that fall. So then you can say your life is undefined because you did not survive. All right, so let's use the slope formula to find a couple slopes here. So the first one, you want to label your points x1, y1, x2, y2, and it doesn't matter if you want to flip-flop those, because when you're going to use the formula, you get to decide which order you want to subtract. So I'm going to do 9 minus -1. So since I did 9 minus -1, I'm going from my y2 to my y1. I'm going to go from my x2 to my x1, being 5 minus -4. These turn into positive, so I get positive 10 over positive 9. So in this case, my slope is 10 over 9, which is a positive, right? So I know without even graphing it that my line will look something like this. It'll be rising from left to right. When I go to the next example here, I have x1, y1, x2, y2. So for this one, again, I'm going to do 8 minus 5. So since I did y2 to y1, I'm going to do x2 minus x1, which will be -7 minus -2. Now remember, when you have a negative that's being subtracted, that's really like addition. So 8 minus 5 is 3. -7 plus 2 would be -5. So my slope here is -3/5. It doesn't matter if the negative is on the top number or the bottom number or the middle. It's the same thing. Now for this one, because I have a negative slope, that means my line is going to fall from left to right or go downward like that. So even without looking at it on the graph, I know that that's what I would expect to see. All right, next one, x1, y1, x2, y2. So my slope is 0 minus 0 on the top. Notice those were the same. So now I'm going to do 3 minus -8 on the bottom. I end up with 0 over 11 because the minus the negative changes to a plus. Remember, when 0 is on the top, it just equals 0. So the line that I would expect here is horizontal, just a flat line, no slope. And then finally, the last one here, x1, y1, x2, y2. I'm going to do this time -8 minus 4. So this time I decided to do y1 minus y2. So on the bottom, I would do x1 minus x2, which both happen to be 5. Now in this case, I got negative 12 over 0, but 0 is under, so that means my slope is undefined. And if I were to draw it, I would expect to see a vertical line. Okay, so now going on to example 5, we're going to continue to use the slope formula, but this time we're given the slope and we're given one of the points, and the other point we're only given half of, or one of the coordinates of the ordered pair. So find the value of y so that the line passing through the points 3y and 1, 5 has a slope of negative 2. So what I would do is if I were going to do this graphically, just to kind of show you how this could work, I know that my slope is negative 2, so that's negative 2 over 1, right? So negative 2 is my rise, and the 1 will be my run. So I'm going to start out by plotting the point that I know. So I know this point 1, 5, I can plot that. Over 1, up 5. Then I want to go to plot the next point. I'm going to go over 3, so it's going to be here somewhere, right? But I don't know where on this line because I don't know what the y is. The y could be a positive up here somewhere, it could be a negative down here somewhere. So this is where my slope comes into play. From my point that I know, I'm going to rise negative 2, which means I'm going to go down 2. I'm going to run 1. And I'm going to continue that pattern, rise down 2, over 1. Now, I ended up on this line, so I know that this has to be my point here, which would be 3, 1. So that tells me that my y has to equal 1. Now, if you have graph paper and you're kind of visual, that method might work for you. But for the most part, we're going to probably do this algebraically. And to do that, we're going to just set up the slope formula. And when we do the slope formula, we are going to plug in the information that we have, and then we're going to cross multiply. All right. Now the slope, if it's a fraction, that's great. If it's not, you'll put it over 1, which is why I wrote m over 1. Okay, so let's start filling in the information here. So my slope, we know, is negative 2, so I'm going to write negative 2 over 1. Then I'm going to do y1 minus y2, which will be y minus 5. And then I'm going to do my x1 minus my x2, which will be 3 minus 1. Now, once you get that all substituted into your slope formula, you want to simplify whatever you can. So I have negative 2 over 1 and y minus 5, but 3 minus 1 I can simplify to 2. And now I can cross multiply. So when I cross multiply here, I'm going to have 1 times y minus 5 on one side and negative 2 times 2 on the other side. And then I have to distribute. And then finish getting the y by itself. So y equals 1. Okay, so let's try the same method now with these other ones here. 0, 3, and 4y, and slope of negative 3. So negative 3 is my slope, so I'm putting in negative 3 over 1. If it was a fraction, you would just don't have to worry about putting it over 1. Okay, so we have x1, y1, x2, y2. Now, I could do 3 minus y for my y's, or I could do y minus 3. Either one works. I like to start out with my variable whenever possible, so it's positive, but I'm going to do it the other way just so you can see what will happen in that situation. So if I do 3 minus y, then I'm going to do 0 minus 4. Now, 0 minus 4 can be simplified to just negative 4. And now I'm going to cross multiply. So on the one side, I'll have 1 times 3 minus y. On the other side, negative 3 times negative 12. Negative 4 will be positive 12. If I distribute a 1, it doesn't change anything. and then I want to get y by itself. Now I subtract the 3, but I still have a negative y there, and I need to get rid of the negative, so I'll divide by 1. That will give me y equals negative 9. And then let's try this one here. Okay, so this time I have a slope with a fraction, and it's a negative. This time I have a slope with a fraction, and it's a negative fraction. So I'm going to have negative 1 over 3. I always just put the negative on the top number. Then over here I have x1, y1, x2, y2. Like I was saying before, the last problem I did 3 minus y, so you could see how we ended up with that negative on our y, but this time I'm going to do y minus 3. So then I will do 4 minus negative 2. 4 minus negative 2 is really addition, and that's going to give me a 6 there. And now I can cross multiply. Now when I cross multiply this time, the 3 has to get multiplied to the y minus 3 and the negative 1 by the 6. So I'm going to have to distribute my 3, giving me 3y minus 9. And now I want to get the y by itself. So I'm going to add the 9, which gives me a 3 there, divide by 3, and y equals 1. Okay, so finally let's go on to rate of change. So this is where slope is actually used in daily life situations, right? So rate of change is just comparing a change in one quantity and comparing it to a change in another quantity. So like I said, hours you worked and how much money you made, or how many miles you drove and how much gas you used. So those kinds of situations. So here we have a table showing the amount of water evaporating from a swimming pool on a hot day. We're going to find this rate of change in gallons with respect to time. So that would mean gallons per hour, okay? So when you have multiple data points here, you're just going to pick 2 of them, provided that the chart is evenly distributed. Now in this particular situation, all the ones I'm giving you, they're all going to be evenly dispersed. You don't have to worry about that. Sometimes you might get a more complicated chart where you'll have multiple data points and it might say find all of the different rates of change, like find the rate of change from 2 to 6 hours, find the rate of change from 6 to 12 hours or whatnot. But for now, we're just going to pick 2 and find the rate of change comparing those 2. So let's just pick these 2 points here. So if I pick the point 2 and 4.5, and then I can pick 6 and 13.5. So now if I'm going to do this, I'm just using slope formula like we've been doing. I'm going to subtract my y's or find my change in y, right? So 13.5 minus 4.5. And then I'm going to find my change in those corresponding x's. And since I did the 13 minus the 4, I'm going to do the 6 minus the 2. So I ended up with 9 over 4. Now, if we were just finding slope of a line, we would leave our answer as that improper fraction simplified. But because I'm finding a rate of change, if you remember when we went over unit rate, we want to divide this out, and you'll get 2.25. And then you would put your units on. In this case, it would be gallons per hour. Okay, so let's try the next one. So here again, we have calories and time. So find the rate of change in calories burned with respect to time, which means our calories is our y and our time is our x. So again, pick any 2 points. So I'm going to pick these 2 this time. So I'll have the 40 and the 500 as my first ordered pair, and then the 80 and the 1000 as my second. X1, Y1, X2, Y2. Just using my slope formula, I'm going to do 1000 minus 500 whenever I have the option. I usually go for the bigger number minus the smaller number. Then I have to follow the same pattern. So since I did Y2 minus Y1, I'm going to do X2 minus X1. And that's going to give me 500 over 40. Now, if you divide that out, 500 over 40, what do you get? Well, right there, I know those. Simplify, 4 goes into 5 once, and then you get 12.5. Now, this is going to be in calories per minute. So the big thing is you're using slope formula, but then you're adding a step at the end where you divide out your answer, get your unit rate, put the units on your final answer. All right, number 6, find the rate of change between the 2 points. So they're already setting them up as ordered pairs for us this time. And then our units are given to us here. The X is in hours, the Y is in kilometers. Okay, so 420 minus 150, and then 5 minus 2, and I went from here to here. So we end up with 270 over 3, which works out to 90, and it's going to be the Y was kilometers, so that goes in the top, and hours goes on the bottom. All right, let's try the next one. Same thing, finding the rate of change between the 2 points. Using that slope formula, I'm going to do 840 minus 200, 7 minus 3. That gives me 640 over 4. But remember, to find my rate of change, I need to divide that out. And I get 160, and the Y is dollars, and the X is months, so it's $160 per month. All right, now the last two, they're not giving us the information in an ordered pair format, so we're going to have to figure that out. In 1995, a library had 16,000 books on its shelves. In 1999, it had 19,000 books. Find the average rate of change in number of books per year. So the books per year tells me that the Y is books and the years is the X. So we know when we do our points, the X values have to be the years and the Y values have to be the books. So in 1995, which is a year, so that's an X value, I had 16,000 books. In 1999, I had 19,000 books. Now I can use my slope formula. 19,000 minus 16,000. 1999 minus 1995. That gives me 3,000 over 4 years. And that's 750 books per year. All right, and then finally, at Memorial Hospital, there were 600 births in 1998. In the year 2000, there were 500 births. Find the average rate of change in number of births per year. So births per year tells me that Y is representing births and the year is X's again. So even though they're giving it to you in this order, 600 births in 1998, 1998 still has to go in as your X, and the number of births is your Y because it's births per year. Same thing in 2000, the year goes in as your X value and the births go in as your Y value. So now this time, if I decide I want to do 600 minus 500, then I would have to do 1998 minus 2000, which will give me a negative. So 600 minus 500 equals 100, but then 1998 minus 2000 is negative 2, which gives me an answer of negative 50. But in this case, it's negative 50. Catch up there. Negative 50. And the units were births per year. Now, the negative just means that there was a decrease in the amount of births per year. It doesn't mean there were negative babies born or anything like that. but it just means that the change that was occurring was decreasing.